Welcome to an exciting journey of language and innovation. In a world where communication knows no bounds, we present to you a groundbreaking project that bridges the gap between two beautiful languages. Prepare to be amazed by the Dzongkha to English translation system. Introducing the exceptional team behind the Dzongkha to English translation system, comprising Mr. Dadrup Wanchuk Sherpa, Mr. Thinley Norbu, and Ms. Sona Myongchun, with guidance from project guide Mr. Karma Wangchuk. For a year, our dedicated group of language enthusiasts has tirelessly worked to bridge the gap between two beautiful languages. Our unwavering commitment, collective expertise, and passion for linguistic exploration have culminated in an innovative solution that transcends language barriers, fostering cultural understanding and forging global connections. In this captivating video presentation, we take you on an immersive journey through the development of the Dzongkha to English translation system. We will begin with an introduction. Next, we delve into the problem statement, addressing the challenges. Our aim and objectives come into focus as we outline our mission to create an innovative solution. The methodology section provides insights into our data acquisition process and the rigorous model training techniques employed. As the anticipation builds, we unveil the results and engage in thought-provoking discussions. We showcase the development of a user-friendly GUI and a mobile app that bring the translation system to the fingertips of users. Witness the model deployment, a pivotal moment in our journey, where the power of technology meets the beauty of language. We candidly share the challenges we encountered along the way, demonstrating resilience and determination. Finally, we culminate with an exciting demo, offering a first-hand experience of the system's capabilities. Introduction. With the advancement of technology, the world has become much smaller. The advancement of technologies such as Google Translator, Microsoft Bing, Amazon Translate, DeepL, and others have played a pivotal role in shrinking the world by breaking down language barriers. These powerful translation tools leverage artificial intelligence and machine learning algorithms to facilitate seamless communication and foster global understanding, enabling people from diverse linguistic backgrounds to connect and collaborate like never before. Most of the languages around the world have been translated. Google Translator supports 133 languages while Microsoft Bing supports 99 languages for translation tasks. While Google Translator and Microsoft Bing have made remarkable strides in language translation, it is important to note that they do not currently support Dzongkha translation. Despite their extensive language coverage, the absence of Dzongkha poses a challenge for individuals seeking accurate translations in this specific language. Problem statement. The research work in Dzongkha language processing is not frequently seen. Digitizing the national language is seen as necessity. Promotion and preservation digitally is rarely implemented. The research work in Dzongkha language processing is lacking, hindering the progress of digitizing the national language. There is a pressing need for more efforts in promoting and preserving Dzongkha digitally, as it is currently an underrepresented area of focus. If someone wants to come to Bhutan, they cannot explore on their own due to language barrier, as there is no Dzongkha translation system. The tourists have to depend on their guide, and there are chances that human translation will be flawed. With the identified problem, the aim of our project is to develop a Dzongkha to English translation system using neuro-machine translation techniques. Building upon our aim, we have defined the following objectives for our project. 1. Conduct literature review on NMT. 2. Prepare Dzongkha to English parallel corpus. 3. Train models for the translation. 4. Design a graphical user interface (GUI) application. 5. Mobile app development. 6. Deploy model in the GUI. Our project journey began by identifying the existing problems and conducting thorough literature reviews, which served as a guiding foundation throughout. With a comprehensive understanding of the subject matter, we listed various methods and carefully selected the most suitable one for our project. Subsequently, we collaborated with the Department of Culture and Dzongkha Development, formerly known as the DDC, to acquire the necessary data for our research. Once the data collection phase was complete, we proceeded with data pre-processing, encompassing crucial steps such as text cleaning, tokenization, and segmentation to prepare the data for training. Using state-of-the-art neural machine translation (NMT) techniques, we trained the model, striving to achieve the desired accuracy. If the desired accuracy was attained, we saved the model, built a user-friendly GUI, and integrated it into our application for deployment. However, if the desired accuracy was not achieved, we fine-tuned the hyperparameters and retrained the model. Documentation was diligently maintained throughout the project, culminating in the submission of our comprehensive report. The dataset for our project consisted of the following components: 2,818 edited BBS news, 6,912 unedited BBS news, 40,882 edited outsourced texts, 112,367 unedited outsourced texts, and 146,975 unedited texts from the CLCS. In total, we obtained a dataset of 309,954 texts from the Department of Culture and Dzongkha Development. After undergoing pre-processing, which involved essential steps such as text cleaning, tokenization, and segmentation, the dataset size was reduced to 232,498 texts, which was utilized for the training process. Data visualization. In Figure 2, we present a sample dataset showcasing the English to Dzongkha parallel corpus. The subsequent table provides essential statistics utilized during the training process, including a training corpus of 232,490 dataset, a train size of 209,241, 90%, a test size of 23,249, 10%, an English vocabulary size of 27,469, and a Dzongkha vocabulary size of 46,700. Figure 3 displays a visualization graph, illustrating the frequency distribution of sentence lengths. Notably, it is evident that Dzongkha sentences with a length of 40 exhibit the highest frequency, while English sentences with a length of 30 display the highest frequency. During the data pre-processing process, we initially selected shorter sentences for further processing. Subsequently, we performed the removal of inconsistent cells and special characters such as hashtag, %, $, at, and. By eliminating these elements, we obtained clean data that was suitable for training purposes. In our project, we employed an encoder-decoder architecture for our Dzongkha to English translation system. The encoder-decoder model is a popular framework in neural machine translation (NMT) that consists of two main components. The encoder component takes the input sequence, Dzongkha sentence, and processes it into a fixed-length representation called the context vector. This encoding captures the semantic and contextual information of the input sentence. The decoder component takes the context vector generated by the encoder and uses it as an initial state to generate the translated output sequence, English sentence. It predicts each word in the output sequence one by one, conditioned on the previously generated words and the context vector as shown in Figure 5. After implementing the encoder-decoder architecture, we encountered certain issues such as the difficulty of capturing long-range dependencies and the potential loss of information during encoding. To address these challenges, we incorporated an attention mechanism into our model. The attention mechanism allows the model to focus on different parts of the input sequence, Dzongkha sentence, when generating each word of the output sequence, English sentence. It achieves this by assigning weights to the encoded input sequence, highlighting the most relevant parts for each decoding step. The Badano attention mechanism is shown in Figure 6 improves neural machine translation models by incorporating a gating mechanism that selectively amplifies or suppresses attention weights based on source target relevance. This enhances the model's ability to capture crucial information, resulting in more accurate translations. By incorporating attention, our model can dynamically align and attend to different parts of the input sequence as needed, giving more emphasis to the important words or phrases during translation. This helps in capturing long-range dependencies and improves the overall translation quality. The model training process encompasses several key steps. Firstly, data pre-processing is performed to prepare the dataset for training. Next, an appropriate algorithm is selected to build the Neural Machine Translation (NMT) model. The model is then constructed, followed by the training phase where it learns from the dataset. After training, the model is evaluated for performance and, if satisfactory, saved for future use. This comprehensive process ensures the development of a robust and effective NMT model for accurate translation. During the result analysis, we obtained the following outcomes for different models. For the Seek-to-Seek model with epoch 20, batch size 64, and a dropout rate of 0.2, the training loss was 0.93, resulting in a BLEU score of 32%. The Seek-to-Seek model with attention, trained for 10 epochs with a batch size of 128 and a training loss of 0.057, achieved a higher BLEU score of 38%. Lastly, the Transformer model trained for 20 epochs with a batch size of 128, a dropout rate of 0.5, and a training loss of 0.71, achieved the highest BLEU score of 40.3%. These results demonstrate the performance variations among the different models, with the Transformer model exhibiting the best translation accuracy. Figure 7 displays a plot of loss values in epochs for a Seek-to-Seek model. The y-axis represents the loss value, while the x-axis represents the number of epochs. In this case, both the training loss and validation loss decrease as the number of epochs increases. This trend indicates that the model is improving and effectively learning from the data. The Seek-to-Seek model with attention performed well during training, as illustrated in Figure 8, where the training loss decreases with respect to the number of epochs. After comparing the top models created by adjusting the hyperparameters, as presented in earlier table, it was observed that the Seek-to-Seek model with attention outperformed the regular Seek-to-Seek model. The table compares the output of 3 models when given the same input sentence to generate a predicted sentence. The results indicate that the Seek-to-Seek model struggled with longer input sentences and performed poorly when faced with unseen sentences. On the other hand, the Seek-to-Seek model with attention produced predicted sentences that were similar to the actual sentences and demonstrated better performance in handling long dependencies. In contrast, the Transformer model showed promising results in dealing with unseen data, even though it did not always provide exact translations as predicted. Despite this limitation, the Transformer model performed well overall and showcased its ability to handle unfamiliar sentences effectively. During the model deployment phase, we initiated the process by designing the UI/UX for both the web and mobile app interfaces using Figma. Subsequently, we opted for the Django web development framework and saved the tokenizer and trained model. Using Django, we developed the web UI, while for the mobile app, we utilized Flutter. We then implemented the necessary backend logic to integrate our model with the UI. Finally, comprehensive testing was conducted for both the web and GUI interfaces to ensure optimal functionality and user experience. This is the prototype of my website, which incorporates several key features. Firstly, it is made bidirectional, allowing translation between Dzongkha and English languages. Additionally, the website is designed to be responsive, ensuring optimal display across various devices and screen sizes. Internationalization support is also implemented. Lastly, convenient features such as a clear button and copy-paste functionality are included to enhance user experience and streamline the translation process. This is our mobile app prototype, created using Figma. The app features a splash screen and a main translation page, allowing users to translate from Dzongkha to English. Additionally, we have incorporated an app drawer, which provides navigation options to explore the developer details and contact us page. Throughout our project, we encountered several challenges that tested our capabilities. Firstly, we faced limited knowledge in certain areas, requiring extensive research and learning to overcome obstacles. Additionally, the high-end system requirements demanded resources beyond our initial expectations, necessitating adaptations and optimizations. The training process proved time-consuming due to the complexity of the models, requiring patience and efficient strategies. Lastly, integrating the trained models into a cohesive system presented a learning curve, requiring careful implementation and troubleshooting. Despite these challenges, we persevered and found solutions to ensure the successful completion of our project. Now, moving on with our demo.
This is our web application that we have developed for our project. In the footer we included the DDC social media links, feedback placeholder where the user will be navigated to mail if he or she wants to provide feedback. And we also included important information regarding the application. This is the top bar, and under that we have navigation bar where user can easily navigate to different section like home, developer details, and to our report. In the developers detail, all the social media links are included in case if anyone wants to contact them. Let's do some translation task using our trained model from Dzongkha to English. After giving the source sentence, the model predicts the corresponding target language. We also included the feature like clear button, copy-paste for better user experience. Let's do some more translation using different examples.
Introducing our mobile app. With a sleek interface, our app offers easy navigation and key features like developer info and contact options. Connected social media accounts. The main page focuses on translating Dzongkha to English. Choose Dzongkha as the input language for Dzongkha sentences, and select English as the target language to receive their translated counterparts.